Hi, this is an introduction to logic. I'm Mark Thorsby, and this course overviews the basics of categorical, propositional, and predicate logic. Today we're going to be looking at just the rules and fallacies. In fact, we're going to be looking at 5 rules and fallacies that you can use in categorical logic to determine the validity of an argument. So we're looking at rules and fallacies today. Okay, let me start off here with sort of a very brief sort of review. I usually always start off with a review, so we might as well keep with the tradition. What I want to start is in our last lesson, we looked at Venn diagrams, and we found out that Venn diagrams provide us really what is a visual means to inspect whether or not an argument is valid. So Venn diagrams allow us to test for the validity of a categorical syllogism. Now, here, let me finish this out. So, a categorical syllogism, remember, is any argument that has 2 premises, 1 conclusion, and has 3 categorical terms. Again, validity is when you have 2 premises, such that if the 2 premises are true, the conclusion necessarily follows as true. Now, Venn diagrams provided us a way of sort of visually inspecting through sort of really just creating circles. I apologize. The circles are sort of freehand, where we would put the minor term here, the major term here, and then the middle term here, and then using either a fill, right, an X, or even an existential marker. We could enter the premises, and then after entering the premises, ask ourselves whether or not we could visualize or really read off the conclusion. If we could, it's valid. If there was any ambiguity or we couldn't necessarily see that the conclusion was represented, then the answer was that it was invalid. If we use an existential marker or a sort of little X-Men symbol here, then we discovered that it would be conditionally valid. Okay? Now, that provided us a really nice mechanical means for testing validity, but is there another way? And the answer is there is. In fact, we're going to see that there are 5 rules for testing for the validity of an argument. And I'm going to go over these 5 rules right now, and then we'll talk about them. We'll see that the first 2 rules involve the concept of distribution. Now, just to remind ourselves, what is distribution? Remember, we said that in an earlier video, and you can watch that video again if you need a refresher, we said that a term was distributed if in the categorical proposition we were able to learn something about the entire class, okay? So let's remind ourselves real quick here about which terms get distributed in which propositions. Now remind ourselves an A statement, right, says that all S are P, right? And we said that what term gets distributed here? We said that the S gets distributed into the P, okay? What about an E statement that says that no S or P? Well, in this case, we say that each term gets distributed, both the subject and the predicate terms get distributed, okay? Now, remember, why is it the all S P? Because you learned something about all of the S's, right? Whereas in the case of no S or P, you learn something about all of the S's and all of the P's, namely that they're always excluded from each other. So both terms get distributed. In an I statement, right, which is some S or P, in order to figure out what gets distributed, ask yourself, what do I learn anything about in an entire class? In the case of some of the S or P, all I'm learning all that means is that there's one S in the universe, and that S is a P. That doesn't tell me about what all of the P's are, and it doesn't tell me about what all the S's are. For instance, imagine, if I said that some firefighters are heroes. Well, that tells me about at least one firefighter, and it tells me about one set of heroes, namely that this firefighter is a hero, but it doesn't tell me about something about all of the heroes and all of the firefighters. Thus, nothing gets distributed. So we'll go like this. I'll sort of put an X here to demonstrate, or two slashes here. Nothing gets distributed. Okay, what about the O statement, which is that some S are not P? Right? In this case, the P is what gets distributed. So I'm going to sort of go like represent it by saying that Because when I say that some S are not P, I learned something about all of the P's, namely that all of the P's in the world are not S's. So for instance, if I said um, some some politicians are not corrupt, right? That tells me that if you take all of the corruption, all of the corrupt politicians, that the S's here get excluded. So I learned something about the P's. So this is the pattern of distribution. So what's the rule? The rule is that in a syllogism, now these are just the propositions, but in a syllogism, the middle term must be distributed at least once. Now remind ourselves what's a middle term, right? And let me sort of just draw one up here. If I say all PRM, right, all MRS, therefore all SRP. Take a look at this statement. So the middle term again is the term that gets I would like to think of the middle term here as something like the glue. It's the glue that binds the subject and the predicate term together, depending upon the pattern of distribution. So the middle term has to be distributed at least once. So let's take a look here. Does the middle term get distributed here? Well, in all P or M, the middle term is not distributed up here, right? Because we said only the S gets distributed to the P. What about over here? All M or S? Well, yes, the middle term gets distributed right here, which means that it passes the rule, okay? Now, if you read a syllogism in which the middle term is not distributed, this commits a fallacy. And what is a fallacy? Literally, the term fallacy comes from the Latin, which means a false argument or a false statement, so a deceptive statement or argument, right? So the fallacy would be an undistributed middle. But we're going to see that in order for a syllogism to be considered valid using these rules, it has to pass all 5 rules, or at least the first 4, and we'll see why in a minute. So this is the first rule. The middle term has to be distributed at least once. If the middle term doesn't get distributed, then that's the undistributed middle. And I'll give you an example here in a minute of what those fallacies look like. Let's take a look here at the second. Let me go down here. The second rule. If a term gets distributed in the conclusion, then it must be distributed in the premises. Okay, so that's quite simple. Again, these first 2 rules have to deal with distribution. So if a term is distributed in the conclusion, it has to be distributed in the premise. Okay, so let's give a sort of example here. Let's say that no P R M, and then we'll say some MRS, therefore some S are not P. Okay, let's take a look at this one. Does this pass the rule? Well, first off, you have to look at the conclusion. So let's take a look at the conclusion here. The conclusion says some S are not P. Now this is an O statement, right? And if you recall up here, right, in an O statement, the P is what gets distributed, right? So let's scroll back down. So that means that the P is distributed here. So the question is the P, if the P is distributed in the middle term, is it distributed up here? Because that's where the P is located. No PRM, this is an E statement. In an E statement, both the subject and the predicate are distributed. So yes, this passes the rule, okay? Now what's important here is what happens if you have a no S, what if you have a no S or P in the conclusion down here? Both of them have to be distributed. So if any term is distributed in the conclusion, look up and see in the premises and make sure it gets distributed up there, okay? Now, if you break the rule here, then that can commit one of 2 fallacies, either the illicit major or the illicit minor. What's the difference here? Well, it depends on where the premise isn't being distributed. So for instance, if I have, let me give you another example here. What if I had something like this? Some PRS, some PRM, some MRS, therefore no SRP. This actually breaks a whole bunch of rules, this argument, right? But let's take a look at the conclusion. In the conclusion, both the S and the P are distributed, right? But up here, take a look. The predicate term is not distributed because In an I statement, both of these are I statements. In an I statement, nothing is distributed. So if nothing is distributed, that means that the P is not distributed, which means that you've broken, in this case, since the P is not distributed up here, this commits the illicit major because this is the major term and this is the major premise. Okay? Now, this ironically commits both of them because, listen, because take a look, the S is distributed in an E statement because both of them are. If you look, and this is the minor term, and in the minor premise, since this is an I statement, the nothing is distributed. So this actually breaks both the illicit. This is the illicit minor fallacy, and this is the illicit major fallacy. Okay, I hope that makes sense. So those are the first two rules that every valid categorical syllogism must conform to. Let's take the third one. Third one here is that two negative premises are not allowed. Now this is interesting. Why is this the case? We'll see that really the first two rules have to deal with distribution. The second two rules have to deal with negative premises and conclusions, negation. Okay. Now, why is it that two negative premises are not allowed? Well, in informal logic, there's a fallacy known as the fallacy of ignorance. Right? And the fallacy of ignorance basically states that if your premise says that something is not the case, you can't conclude that something is the case. Okay, so let's write this out. Is that, or basically, it's simple. If you argue that you don't know, you can't conclude that you do know something. It's pretty simple. Sorry, my handwriting is sort of poor today because I'm using a different format. So that's the fallacy of ignorance, or arguments from ignorance are always fallacious, right? Now, that means that if you have a syllogism that the first premise is negative and the second premise is negative, the answer is, what can you conclude? The answer is you can't conclude anything. Because in order to make a statement, in order to make an argument, remember, an argument is when you say something is the case, right? And you can't have two negative premises and say that anything is the case, because all you've said is that something isn't the case, right? I don't know if that makes sense. And this is what's called the fallacy of exclusive premises, right? So, for instance, let me give you an example. What if, for instance, I said that no Democrats are good politicians, right? And then I said something like, no good politicians are Republicans. Therefore, and then I said something like this, some Republicans are Democrats. Now that's a horrible argument. That doesn't make sense. I guess from one election to another, they could, a Republican or a Democrat could switch. But you can see here is that if this is my claim, regardless of what R&D stands for, right? This can never count as evidence, because remember, a premise is supposed to be, a premise is supposed to be evidence. And if my evidence is simply that something is not the case, how can I conclude that something is the case? And even if this was a negative premise, it wouldn't work. So you can never have two negative premises. That's a pretty simple argument. So let's see here then Rule 4. Rule 4, it also has to deal with negation, right? It also has to deal with negation like Rule 3. And that is that a negative premise requires a negative conclusion. And a negative conclusion requires a negative premise. So you can't have two negative premises, but of course you can have one negative premise. But if you do have a negative premise, you have to have a negative conclusion, and vice versa, right? And if you break this rule, that commits the fallacy of either drawing an affirmative conclusion from a negative premise or drawing a negative conclusion from an affirmative premise. That's sort of wordy, sort of complicated to say, but that's essentially the rule, right? So the rule is that a valid syllogism, right, if there is any negation in the conclusion, there must be a negative premise. And if there's a negative premise, there has to be a negative conclusion. But remember, there can only be one negative, right? Otherwise, you commit the fallacy of the exclusive premises, okay? I don't really know if I need to write anything out here, but that's just the second rule, right? A negative premise requires a negative conclusion. A negative conclusion requires a negative premise. So what's the fifth rule, right? The fifth rule here actually concerns the Aristotelian model of the existential fallacy. So here we have to remember the difference between Aristotle and Boole on the existential fallacy. Remember, and I've gone over this over and over by now, so I'm sure you've memorized this. Aristotle thinks that a universal can allow you to conclude a particular, whereas Boole thinks that universals can only end with universals. They can never end with a particular. Okay, that's not possible. So, what is the Rule 5? Rule 5 says if both premises are universal, the conclusion cannot be particular. It cannot be particular because Rule 5 here conforms to the Boolean interpretation, which means that if you break this rule, you commit the existential fallacy. Now, there's a sort of caveat. There is an exception to this rule. The exception is if you assume that Aristotle's model for the existential fallacy is correct, right? Which means that for Aristotle, you can have universal premises in a particular conclusion. Okay? Now, what does that mean? It means that you can use these 5 rules, and if a categorical syllogism passes the first, second, third, and fourth, but not the fifth, then it's conditionally valid. If it passes all 5, then it is unconditionally valid. And if any one of these first 4 are broken, it's invalid. And it may even be invalid even if it passes Rule 5. I'm sorry, even if you take the Aristotelian model. Because remember, if you make arguments about unicorns, you break the existential fallacy regardless, okay? And that's an important difference here. So let me sort of review here. That means that we have 5 rules. Let me switch colors. The first rule, again, is that the middle term must be distributed once. At least once. Okay? The second rule is that if a term's distributed in the conclusion, it must be distributed in the premise, right? So I guess I'll write this, is that if a term in the conclusion gets distributed, I'll just put DIST here, then it must be in the premise. Okay, so these are the first 2 rules, and again, these both have to deal with distribution. Okay, the third rule, right, is that there's no, is that you cannot have, there's no exclusive, let's see, what's the word I want to say? Let me actually go back. Oops, sorry about that. Right. 2 negative premises are not allowed. Okay. The fourth rule is that if you have a negative premise, I'll just write it like this: a negative premise requires a negative conclusion, and vice versa. So it's that if you have a negative conclusion, you must have a negative premise. Okay, and then so these 2 rules have to deal with negation, and then the 5th rule, to change colors again, it has to deal with universal premises require, whoops, that, what? Sorry about that. Universal premises require a universal conclusion. I'll put two universal premises. Now, this fifth rule has the exception, possibly, due to the existential fallacy and the Aristotelian model. So, every valid syllogism must conform to all four of these. Every unconditionally valid syllogism must conform to all five of these, right? And if any one of these rules gets broken, it's either going to be conditionally valid or it's going to be simply invalid. Likely it's invalid, okay? So those are the five rules, and of course each of them comes with a fallacy, right? So the fallacy here would be the undistributed middle. The fallacy over here is either the illicit major or the illicit minor. The third one here is exclusive premises. And then this is drawing an affirmative conclusion from a negative premise and drawing a negative premise from an affirmative conclusion. And this, of course, is the existential fallacy. Okay? So these are the five rules. And so let's sort of take a look at the homework here and see what you're going to have to do for the homework. Let's take a look here. And if you take a look at your book gives you examples for each of these fallacies, right? And it goes over all this stuff. Okay, and also if you want to take a look at the proof is rather sort of laborious, so I'm not going to go over the proof for it. I just want you to learn at this point what the rules are and learn how to apply them. And you'll see that once you get these rules down, it is going to be much, much faster to determine the validity of an argument. Okay, so what you're going to have to do let me see if I can make this a little bit bigger for you. All right, so what you have to do for this first argument, for this first section in the homework, is they're going to give you a form, right, and the figure and the mood. There's a AAA3, and you have to figure out whether or not this breaks any of the five rules. So all you need to do is sort of reconstruct this, and I'll sort of do one for you real quick, I guess. It's a new one. Oh, no. Okay, so let's do this first one here for you so you can see what it looks like. Okay. I guess I can't do that. Okay, a triple A3. Now, the best way to start this is to always start with the conclusion if you're going to do a reconstruction. An A statement is an all S or P, so this is going to look like all S or P. Now, this is the next thing to look at when you're reconstructing. Take a look at this guy, and that's the location of the middle term. And you'll remember that the middle term has to, this is going to be all. The middle term is going to be here for a 3. R. The P is the major term, so you put it up here in the major premise. And S, okay? So this is what it looks like. So now let's ask, does it pass the five rules? Okay? And it may be helpful here to sort of draw it out like this. Here's the five rules. I'm not going to write them out because my handwriting is horrible on this computer right now. Remember, the first one here was a middle term has to be distributed at least once. Well, in an A statement, the first term gets distributed, so the middle term does get distributed. We passed that rule. Second one, if a term is distributed in the conclusion, it has to be distributed in the premise, right? So let's take a look at it. All S or P, the S is distributed right here. Does the S is distributed in the conclusion? Is it distributed in the premise? No, it is not. Because look, the S is in the second position, and in the first one, only the subject term is distributed, not the predicate term. So no, it didn't pass this. And so what fallacy gets committed? Because that's what they're going to ask you. Well, since it was the minor term that was distributed in the conclusion, and it's not distributed in the minor premise, this commits the illicit minor fallacy. The illicit minor, okay? Invalid, therefore. Now, see, wasn't that faster and easier than looking it up in the table and or drawing a Venn diagram? Now, we could draw a Venn diagram to test if you want. I won't do that. But that's how you're going to do the homework here. Now, remember, when you reconstruct these, always start with the conclusion, then take a look at the middle term, then sort of fill it in and run through the rules, okay? It's pretty simple in that regard. Okay. The next thing, oh, let's see. They say, oh, they actually want you to check your answers by constructing an event diagram. So I guess you can go ahead and do that, but it always works out. Okay, what do you have to do in the second one? Now, the second section here is use the 5 rules to determine whether the following standard form syllogisms were valid from the Boolean standpoint, valid from the Aristotelian standpoint, or invalid. Okay, so you need to see if they are going to be conditionally valid, unconditionally valid, or just simply invalid. Okay, so let's do another one here, and then they want you to construct a Venn diagram for this. So maybe I will do it all for you. So let's take this first one right here. Okay. Okay, some nebulous clouds are clouds of gas. Some clouds of gas are objects invisible to the naked eye. Therefore, some objects invisible to the naked eye are nebulas. Did I say nebulous? I meant nebulas. Okay, first thing to do here is to just recognize what we're actually looking at here. And in fact, it may be easier than sort of, you could say that this is N, and this is C, and this is C, and this is, I guess, O. And then this is O, and then this is R, N, right? So what does this look like? Let's reconstruct it. And you can also take a look at, this is an I. Some clouds of objects are invisible to the naked eye. That's an I. And then some of them are, and that's an I. So we have a triple I, okay? Whereas the middle term, well, you can see here the middle term's right here, right? That's 1, 2, 3. 1, 2, 3, 4. So that's a triple I 4. Okay. So is this valid? Well, let's sort of write it out here. Some N or C, some C are O. Therefore, some O are N. Okay. So is this valid? Let's use our rules again. 1, 2, 3, 4, 5. All right. First rule, right? The middle term has to be distributed somewhere, right? The middle term has to be distributed at least once. But wait a second. In an I statement, nothing is ever distributed, right? Because remember, distribution for the A, the E, the I, and the O, in the A, the S gets distributed. In the E, the S and the P get distributed. In the I, nothing is distributed. So right away, you can see that this breaks the very first rule, right? And what fallacy does it commit? It commits the undistributed middle. Now, one of the things that's interesting here is that means that any argument that starts with the double I is always invalid, right? Because that means the middle term can never be distributed. So, in fact, once you just look and see that, if you ever see an argument that starts with some, blah, 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 some, blah, 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 R, blah, right? That means that it's always going to be invalid, okay? Now, they want us to do a Venn diagram. I'll sort of try to draw one real fast here, just to show you what you want to do here. So this is going to be O, N, and C, right? So some of the N's are C's. So some of the N's are C's. Then that means you have to put the X here or here. I don't know where. So let me change my color here. So I'm going to put the X on the line, right? For that premise. Now if I need to diagram the second premise, some of the C are O, some of the C's are O's. I don't, either it's going to go here or it's going to go here. I don't know. So it goes on the line. You can see here in both cases, it's sort of unknown what the case is. So when it says that some O are N, I have no idea, but maybe these X's are supposed to go here, right? Which means that I have no idea. This is an invalid argument. And our Venn diagram proves that as well. So I hope that makes sense. So that's what you have to do for that section of the homework. Okay. Let's move here to the third section in the homework. This is just true or false. It's going to ask you sort of questions. I won't answer those. And those are the 5 basic rules. Now, you'll see that once you get a handle on using those 5 rules, things are going to be much, much easier for you in terms of validity. It's much easier to check your work, especially your Venn diagrams. And I'm sure that some of you, when you actually started doing the Venn diagrams after our last video, actually found that they're more difficult to interpret and actually to perform than you probably thought. So these 5 rules, you should just commit them to your memory and get used to using them, because it's going to make your life a whole lot easier. Okay? Thank you very much for watching, and I'll see you guys online. Okay? Bye.